Hello, good afternoon. Okay, if there are people watching, can you guys say hi? Hi kayo sa chat para alam kong may tao. Okay. Looks like there aren't that many people yet in the stream, so we can wait a bit for some people to show up. Okay, I got a question from Jason. He's asking, will you give the answers for round 9? So actually, what happened was last week's stream didn't push through because the streamer had internet connection problems. But we had um, we had some kind of discussion in the Discord server. So if you're part of the Discord server, you can go look there to see the solutions. If you're not part of the Discord server, you should email us. ask@noi.ph. Email us with your name and school and grade level so that we can give you access to the Discord server. Okay. Okay, I guess we can start. So we've been doing this for a while, so this isn't new anymore, but just in case there are some of you who still don't know, I'm one of the people behind IPH, one of the trainers, and my name is Vernon. I'm Vern Goods in Code Forces. I'm not the one who prepared the round today. Today's round is actually prepared by Kirk. So, siya yung KKBB on Code Forces. And, yeah. I hope you guys enjoyed the round. I think the problems are interesting. Did you find the problems interesting? I hope you did. Sige. Well, let's just get started. So first we have problem A, akit bahay climbing device. Okay. Ano ba yan? What is the problem asking for? You're given three stool heights, A, B, C, and you want to know if it's possible to arrange them so that in some order, so let's say ganyan, so that this one is plus 1 of the one before it. Okay, and there are several ways to go about this. Since there are only 3 stools, one thing you can try is, well, one of them has to be the smallest guy, one of them has to be the middle, and the last one has to be the tallest. But you don't know which is which, the input is shuffled. So one thing you can do is try, okay, maybe, let me try, assuming A is the smallest, B is the second smallest, and C is the third smallest, or C is the largest. Are the values of A, B, and C correct? Okay. Or you can try maybe A, C, B, or BAC, BCA, or CAB, or CBA. Okay, so you try all 6 possible orderings of A, B, and C, and these are the only ones that are possible. And you check, is the smallest one, okay, is the second smallest one equal to 1 plus the smallest, and is the largest one 1 plus the biggest. Okay, so that's one way to do it. Let's see how uncode yan. Let's go here. So first, I need to read the input, right? So A, B, C. Okay, so if you haven't seen this before, this is just the way to read multiple inputs, the integers that are in one line. You can look at the past streams. Actually, you can look at round 8. I specifically talk about how this works in the first part of round 8. Okay, but anyway, let's just read the 3 inputs. Okay, and then what do I do? Let me say can. It's one of the following possibilities, right? And then later on, I'm going to print yes if can, otherwise no. Right? So what are my possibilities? Either A is the smallest, so I have to check, is B equal to A plus 1? And C is equal to A plus 2? Or I'm going to try A, C, B instead. So C is A plus 1 and B is A plus 2. Or, okay, and then you can, okay, let me just do it. Or, what's our next possibility? Okay, let me just write this. A, B, C. Pwedeng A, C, B. Yung next one is B, A, C. B, C, A. C, B, A. C, A, B. Let's say, ganyan. Okay, so here I would have, I need to check A is B plus 1 and C is B plus 2. Or B, C is B plus 1 and A is B plus 2. Or B is C plus 1 and A is C plus 2. Or A is C plus 1 and B is C plus 2. Okay? Obviously, that's not the smartest way to solve this problem, but it works. Okay, we just basically try all the possibilities. And you can notice, how do you make this solution smarter? Well, it's not important really that I know exactly that B is A plus 1 and C is A plus 2. I just need to know that A plus 1 and A plus 2 exist in the remaining numbers, right? So I can rewrite this as like, okay, these two. Like, I don't really care which one is which, if it's B or C that is A plus 1 or A plus 2. I just want to make sure that A plus 1 and A plus 2 are in one of these two, right? So I can say, I can simplify this condition to a plus 1 in BC and a plus 2 in BC. Right, and then you can do that with the rest. I can say b plus 1 in AC and b plus 2 in AC. Okay, like this. So, pwede rin yan. Okay, and then actually, you know, I can simplify this even further. Well, I can add a in there. It doesn't really matter because a plus 1 is not going to be equal to a anyway. A plus 2 is not going to be equal to a anyway. I'm just doing this so that everything becomes nice. You know, yung B pwede ko rin lagay sama dyan. Yung C pwede ko isama dyan. So it doesn't really affect the conditions. And now, it's almost the same thing, right? So if you're doing the same thing for the three numbers A, B, and C, you can rewrite this using some kind of loop. Right, so I can say can is false, and then for x in A, B, C, I want to know is x plus 1 in ABC and x plus 2 in ABC. If it is, then it means I can make a sequence of 3 stools where the smallest stool is x, and that means I have one possible solution. So this is OR. Okay. Yeah, and this is one of the simplest ways to solve this problem. There are other ways, like if you know how to sort, then the problem is actually much easier because you don't have to think about the shuffle anymore. Just sort them and then check, is the middle guy equal to, like, let's say S is ABC. You can sort them. Okay, let me do that in a different window. You can sort them. Then what do I want to do? Well, I just want to check. I think I have to do this. I just want to check is S1 equal to S0 plus 1 and S2 equals S0 plus 2. Right? So that's another way. Okay. So Python trick, for those of you who use Python, there's a nice way to write something like this. If you want to just check, does the condition hold for any item in a list? You can simplify this by saying, write your condition for x in ABC. Okay. And this loop is doing exactly the same thing as this any in Python. So very neat shortcut if you haven't seen it yet. Okay, and I can clean this up a little bit more. I can say S is ABC. Okay, actually I don't even need to read to split the input into 3 numbers. I can just directly say That's S, right? Okay, and you can basically have a one-line solution like this. Okay? So, bibilisan ko na ng konti kasi I think everyone solved problem A anyway. So let's move on to the more interesting ones. If you have any questions, just ask them in the chat. I will get to them as soon as I can stop and take a look at the comments. Okay. Now let's go to problem B. So, ano yung problem B? This time, it's actually quite similar to problem A. You want to know, can you make, let's call it a ladder sequence. Ladder sequence means every item in the list. You can form, if you sort the sequence, every item in the list is one greater than the one right before it. Okay, so now we're trying to figure out, is it possible to create a ladder sequence by adding one ladder, by adding one stool, and if yes, what is the stool that we should add? Right, so how do we do that? Any ideas? Okay, so maybe let's not think about what is the stool that we should add yet. Let's first think about, how do we even know if the answer is yes or no? Well, there are several ways again. So I guess the easiest one is, if you know how to sort, you can sort them first. And then, well, paano mo malaman kung no yung sagot? Diba, parang kung may butas sa gitna. Like if you sort them, and then there's a gap that's really large. May butas sa gitna. And the gap size is greater than 2. Then it means there's no way for you to create this ladder. Right? So that's one way. You can sort first and then check. If you don't know how to sort, well, kaya pa rin. Ano ba pwede? Well, how do we know na walang butas sa gitna? Okay, let's actually simplify it a bit. Yung original problem allows us to have one hole, exactly like one hole in the middle, and then we can add a stool, right? But let's simplify it first. Let's say we just want to check, do we already have a ladder sequence or not? How do we do that? Without sorting the input. Well, you're guaranteed that the numbers in the input are distinct. So that means what? You only have two possibilities. Either your smallest stool and largest stool is exactly the right size to have exactly n guys in the middle, or to have exactly n minus 2 guys in the middle, or their gap is actually too large. So that means there will be stools in the middle, pero may mga butas dyan. right? So another way to figure out the answer is look at the maximum minus the minimum. Okay? Check if it's the right size, if the gap is just right. Okay? Part 2. So if the answer is yes, we need to figure out what's the ladder that we will add. Right? So there's an easy case, a new easy case. Well, if you already have a ladder sequence, let's say 1, 2, 3, 4, 5, what do we add? Well, we can just add the maximum plus 1, right? So let's add 6. Okay, so case 1. Case 2 is meron kang isang butas. Oh, I skipped the part about how do you do this check. If you have a hole, if you have a single hole. Okay, but you can think about it, right? It's not very different from checking if there are 0 holes in the sequence, right? You can still figure that out by looking at maximum minus minimum. Okay, so case 2 is, yes, there's a single hole, so 0 holes. And now we just want to know sino yung butas na yun, right? So how you would do this depends on what you did for step 1. Right? If you sorted first, then you can check the items one by one and then find which one. Okay, you sort them, say 1, 2, 4, 5, 6. You find the first guy who is not equal to, this is AI, not equal to AI minus 1 plus 1, and then you know there's the hole, right? That's where you have to put the stool. How about if you didn't sort? What do we do? Okay. Well, if there's a single hole, the stool that we have to add has to be one of the numbers between the minimum and the maximum. Right? So here's what we can do. Let's check one by one. All of the numbers from minimum plus 1 to maximum minus 1. If x is not in the list, yun yung missing stool. That's what we have to output, right? If x is not in the list, that's the missing stool. X is the answer. Okay, I'm going to show the solution where you don't sort, because I think it's a bit more interesting. If you know how to sort, then the problem isn't interesting for you anyway. By the way, if you do the sorting solution, you would be able to solve the problem in log n time, which is fast enough. Okay, if you don't know what this means, you should check out the past rounds and the past streams. And we discussed we discussed this big O thing in the past rounds. Okay, so let's go to the code. Okay, so first I need to read n, and then I want to read the heights. Okay, then what? I want to check if max height minus min height, what do I want to check? Well, dapat yung butas, there's either a single hole, in which case max minus min has to be equal to n and minus 1. If there's a single hole. If there's no hole, then max minus min has to be equal to n. Okay, I think I said that in reverse. But anyway, the important thing is it's one of these possibilities, right? Okay, it's n if there's a single hole. It's n minus 1 if there's no holes. Okay? Then the answer is yes. Otherwise, the answer is no. And then we need to find which one we want to add. Right? So I'm going to try for all x in range min height plus 1 to max height minus 1. If x not in height, then that's what I print. Right? There's one more thing we have to handle. If there are 0 holes, then the answer won't be within this range, right? Because it's going to be height plus max height plus 1. Okay, you can add a different else clause for that. You can do like, okay, elif max minus min equals n, and then do something else, minus 1 actually, and then do something else for that. Okay, but you can also just do this, you know. Right, go all the way up to max height plus 1. Because anyway, if there are no holes, none of the earlier numbers are gonna work, and you won't be printing anything. Okay, and then once you print something, you stop. There's one problem with this solution. Can you guys tell me what it is? Yes. Let me just report these spammers in the chat. Okay. Yes, it's going to take too long. Why is that? Well, this checking if a number is in a list potentially takes O of n time. And this range is also potentially very large, right? This is also O of n. So actually this one is n squared in total, and n in the problem is 10 to the 5. So that means n squared will be 10 to the 10. So if you guys remember, a computer can roughly do 10 to the 7 Python operations in 1 second. So if you're going to do 10 to the 10 operations, that's going to take too long. So you're going to get time limit exceeded if you have this kind of solution. Okay, instead, what do we do? Well, so there's a data structure in Python called a set. So what does a set do? You can add stuff to a set. You can check if some item is in a set. You can also remove items from a set. Okay, and this works like the mathematical set, meaning you don't have duplicates stored in this S. If you add X, there's only one instance of X in the set. If you remove X, so if you do like S dot add 1 and S dot remove 1. Okay, let me show you how it works. Get rid of this first so that I can show you how it works. Actually, let me do that in a separate window. Okay, so this is how it works. You can make a set S, you can add a number, and you'll see that you have a set with single number 1. And then I can add 1, but since it's a set, it's already in the set. If I remove it, I get an empty set again. This is how Python prints an empty set. And you can check 1 in S. You can check if a number is in the set using this syntax. So here it was true, there it was false. And we can fix the code up here by using a set instead. Okay, and you can actually also create a set from a list. Just put the list inside the constructor for the set. And we change this to hide set. Okay. I'm not going to show how it runs anymore. Let's just discuss. Why is this faster? Well, yung set in Python does some kind of magic behind the scenes so that you can insert, remove, and check elements existence in O of 1 per operation. O of 1 meaning it happens instantly. Doesn't depend on how big the size of the set is. Okay? Ano yung magic na yun? It uses the same magic as dictionaries. So it uses hashing for this to work. So if you haven't seen that before, I have a link to how hashing works in the round 1 stream. So you can take a look at that. Pero that's how it works. Okay, in C, if you're coding in C++ or Java, so C++ meron yan, you can use set and then put the type of the set in angle brackets, put the type of the elements in angle brackets. So Java, you also have, I believe, hash set is what you would have in Java. Okay, so that's how you can keep a set of numbers and allow yourself to check, is there a number in the set quickly. Okay, and let's say you didn't know there was a set thing in Python. How would you do it? Well, basically, ano bang ginagawa natin? Let's go back to the drawing board. Okay, let's go back here. Yeah. Okay. So let's say meron tayong 1, 3, 5, 7, 9, 8, 6, 2. Okay? We know that the missing element is 4. What are we trying to do anyway? Well, we're trying to check, is 1 in there or not? So check yes. 2, is it in there or not? 3, 4, x, 5, right? 6, 7, 8, 9. Well, basically, we want to like have this list of this table of checks and x's, right? Ano ba yung check and x na yan? That's actually parang true or false, right? So we can represent a set with a Boolean list where, let's call it L, let's say Li is true if I is in the list, otherwise false, right? So of course, if you literally do this I in L, it's going to take linear time O of n per number, but we can read all of these numbers in advance, right? And then if we see a number, all we have to do is actually mark the position in the list for that number. Sorry. Right? Sorry. So we can build this Boolean list in advance. And then after we've built it, we can run through it and then see which one isn't marked, and that's the answer. Okay, there's a little bit of complication that you have to deal with if you're gonna go for a solution like this, because the heights in the problem go up to 10 to the 9. And you can't actually make a list of size 10 to the 9 in Python. That's going to be too slow and too memory intensive. So there's a way around it. If the answer is yes, you know that the range of the numbers is going to be only up to 10 to the 5 anyway. So you can sort of shift the indices around. Let's do it this way. Lx is true if x minus the minimum is in L. Okay, so that way, since your range, this x minus minimum is at most the maximum minus the minimum. And if the answer is yes, then we know it's less than or equal to n, right? So we only need n positions in the list. Okay, so that's one other way to go about it. Okay, it's not the best way. If you know how to use set, everything becomes more convenient. Just use the set, right? That's what it was invented for, so that you don't have to do this dirty trick. Okay. So now let's go to problem K. So ano yung problem K? And I guess we want to start with the drawing first. So what do we need to do in problem K? Okay, this time the positions of the stools are fixed, right? So you can see in the second sample case, 2, 4, 3. Okay, so make sure you understand the problem properly. So 2, 4, 3, the answer is not 0. Because you can't rearrange the stools. You can't make them 2, 3, 4. Okay, so these guys are fixed in position. The only thing you can do is raise or lower a specific stool. Okay, so the answer is 2 here. Kasi what do? 2, 4, 3. We lower the stool for 4 into 2, 3, 4. 2, 3, 3. And then we raise the stool 2, 3, 4. So the answer is 2. Okay. So naturally, you see the bounds and you're thinking like, yeah, I have to come up with something smart. Dapat O of n or maybe n log n something. Okay, but you don't have to think about that immediately. Actually, it's better to start by any kind of solution that just works. Right? And then think about how to optimize the solution later. Okay? So, ganun muna. So, how do we even get any solution that works, even though it's slow? Just something that will give me the right answer. Well, how do I know what the minimum number of stools to change will be. Okay, so let's have some stools. Okay, so maybe I know that, for example, I can keep these 4 stools. Their heights are just right. And I have to get rid of the other stools. Or not get rid, change the heights of the other stools, right? Okay, how do I know that? How do I know the best possible sequence of stools to keep here? And then I'm gonna remove the rest. So I have one idea here from Naomi. Per number, make some list that fulfills the needs to be increments of 1 rule. Tapos compare which ones take the least steps. Okay. So let me try to understand ano yung sinasabi. So I think the idea is, well, you can always at least keep 1 stool, right? And then change everyone else, right? Okay, there's some extra condition you have to be careful of, which is if you have a small stool in the middle, hindi pwede kasi magiging negative yung stools before it. Okay, but let's ignore that for now. Okay, that's an extra detail that we can take care of later. Let's get the main idea of the problem first. Okay, the main idea is you can always pick 1 stool, tapos, change everyone else to make a ladder sequence. And then maybe you don't need to change everyone kasi yung mga ibang stools are just the right height. Okay, but definitely there's 1 stool in the optimal solution that you don't need to change. Okay? So the answer is always at most n-1. So that's the first observation that we have. Okay, the second observation is, well, yeah. Well, we don't know ano yung stool na i-keep natin. Well, yeah. It could be this guy. It could be that guy, that guy, that guy. Well, baka hindi pala yan yung best sequence. Maybe this one is actually the best sequence, like going here and then there's some other guys up there. Maybe this one is actually the best guy. But there has to be one of them that is in the optimal sequence that you keep unchanged. Okay, so what do? We have a computer. We know the computer can compute fast, can do lots of computations fast. So rather than trying to come up with a smart rule to figure out which stool do we keep, okay, let's just try all of them. Okay, let's call it like the anchor stool. Okay, let's try all possible stools. Let's check what if stool number 1 is the anchor stool. What if stool number 2 is the anchor stool? Stool number 3 is the anchor stool, and so on. And then, if we fix an anchor stool, we will know how many of the other stools do we need to change. Right? Then what? Well, we want to take the minimum, so let's take the minimum over all of those choices. Okay, so that's one possible approach. Okay? So, kunwari, ganyan. Let's take a random sequence. 1, 3, 1, 4, 1, 5, 9. Okay? So, kung 3 yung anchor, well, dapat yung sequence natin ay 3, 4, 5, 6, 7, 8. Right? And then we check. Equal ba yan? Equal ba yan? Equal ba yan? Right? Well, in this case, all of them are not equal. So if 3 were the anchor stool, then we actually need to change 5 other stools. So 5 yung sagot. And then let's try kung 1 yung anchor. Well, that means dapat 0 to. Okay, this is actually not allowed, but let's ignore that for a moment. It's 1 to, it's 2, 3, 4, 5. Okay, wala pa rin. Wala pa rin nag-equal. So actually, that's 5. Okay, maybe I picked a bad example. Let's change the example a bit. Let's cheat. Let me change some numbers here. So kunwari, this one is actually 2. And this one is 7. Right? So in this case, if we kept 3 as the anchor, then itong 7 we don't have to change. Okay, so the answer here will be 4. Okay? Tapos, what do I do? Let me change this. Let me also change this. Gawin natin 5 to. Okay. Actually, that's... Yeah. So, ano mangyayari? If I make 1 the anchor, then I keep this unchanged. I can keep this unchanged. And I can keep this unchanged. So the answer for this one is I have to change 3 other stools. Okay, again, may 0 dyan. Let's ignore the fact na 0 yan. Let's ignore the fact na kailangan positive lahat ng heights for now. Actually, if you want, we can change the example. We can add 1 to all the numbers, and then we won't have the problem. But I think you get the idea. So let's just not do that. Okay, then what? Sige, so try muna natin i-code para may feeling tayo for what the solution is. Okay? So paano ba i-code yan? So again, like before, we have to read the input. Tapos, we're gonna try all possible anchors, right? So, kung meron tayong anchor, dapat may required heights. So, ano yung required heights? Well, I want to go like height of the anchor plus j minus I. Right? Is that right? So the required height at position j is the difference from j minus the anchor position. Right? Okay. And now, how do I count the number of stools that I need to change? Well, it's how many heights are not equal to the required heights, right? So for j in range n, if height j is not equal to the required height j, then stools to change add 1, right? So let's call it 0 initially. And then our answer is going to be, well, we know it's at most n minus 1, but possibly smaller. So we can say answer, if the current stools to change is smaller than the answer so far, then we want to update the answer, right? And then finally we print the answer. Okay. Shall we check that it works? Okay, seems to work. I got, there's actually, madami palang messages sa Discord. Let me check the Discord messages first. Ah, wala. It's just memes. Never mind. Okay. Why is there a spammer in our chat? Oops. Push the wrong button. Okay, anyway. Sige, so going back. So this will solve the problem. Kaya lang, anong issue? Well, again, it's too slow, right? This is O of n, this is O of n, and we're doing this O of n thing O of n times. So again, the total is going to be O of n squared. And that's too slow because n is 10 to the 5. So we need some ideas to make this faster. Now what? Ano kayang magandang idea? Let's go back here. Actually, let me redo this example. Let's make a nice example so that you guys can see. Okay, so let's try to examine what we're actually doing on this random example. So kung 4 yan, ano yung required heights ko? Dapat 4, 5, 6, 7, 8, 9. Right? Then we see that this guy doesn't need to change. Tapos, kung siya yung anchor, okay, and then this guy doesn't need to change. And then pag siya yung anchor, ito yung sequence natin. Are you guys noticing something? Okay, let's continue. So kung siya yung anchor, actually that's gonna be too small. Magiging negative yung kalikot niya. So let's skip that. So let's say kung siya yung anchor, nangyari 8, 7, 6, 5, 4. Okay. Something fun going on here. Do you guys see it? Kung siya yung anchor, nangyari, dapat 6, 5, 4, 3, 2, 1. And then we don't have to change this. We don't have to change this. We don't have to change this. So the answer for this one is 4. This one is 3. This one is 3. This one is 4. This one is 3. Do you notice something? Okay, maganda yung observations sa chat. Sabi, somehow, parang pag same, somehow you can group the numbers if they can be made part of the same chain somehow, right? More precisely, let's see what's happening. Yung required heights nito is the same as this one, right? It's also the same as this one. And the stools that we keep and change are going to be the same in all of those three. anchors. Right? It's the same. I keep 2, 3, 6. Here, if the anchor is 3, I also keep 2, 3, 6. Same here, right? So I think that I can save computations if I don't keep repeating this, compute the heights, the required heights, over and over again. I can sort of reuse the answer here for the answer here somehow. Kasi pareho lang sila eh. Right? And actually, I don't need to check that again. In other words, right? What do I do here? I can group the numbers by their required height sequence. Right? So sabihin ko, itong 1, 2, 3, 4, 5, 6 height sequence, the stools na gagana sa kanya without changing ay 2, 3, and 6. So let me write that here. Kung yung sequence ko ay magiging 1, 2, 3, 4, 5, 6, I know that I can keep 2, 3, and 6 unchanged. Actually, I don't really need to care which ones they are. I just need the count anyway. Okay, so I know if my sequence is 1, 2, 3, 4, 5, 6, I can keep 3. If my sequence is 4, 5, 6, 7, 8, 9, what do I know? Yung 4 tsaka yung 8, hindi ko kailangan galawin. I know that I can keep 4 and 8. I can keep 2. Right? Okay, so what do I do here? Maybe I can first try to do this grouping para malinaw. Okay, let me group all the numbers. And then once I have the groups, well, I know all the possible ending ladder sequences that I can possibly make. So in this example, I know that the ladder sequence is going to end up being either 1, 2, 3, 4, 5, 6 or 4, 5, 6, 7, 8, 9. And there are no other possibilities because I've tried all of them. Right? So now I just want to know if my ladder sequence is going to end up being this guy, ano yung sagot? If the ladder sequence is going to end up being this guy, ano yung sagot? Right? And how do I do that? Well, the answer is the number of stools that I have to change is going to be n minus the size of this group. By size of the group, I mean how many numbers, like how many anchors have the same ladder sequence, end up with the same ladder sequence. So n minus 3, 3 yung sagot pag ito yung ladder sequence. Ito, n minus 2, 4 yung sagot pag ito yung ladder sequence. So let me try to damn. I hate this spammer. Man. Okay. So let me try to organize my thoughts and write that in code para malinaw. So what am I going to do instead? Okay. So somehow, anong gusto kong gawin? Let me make a dictionary. Call it group size. And then for every anchor sequence, I know ano yung required height nung for that guy, right? So if I see a new anchor that fits the same sequence of required heights, I'm going to increase the group size of that by 1. Okay, so well, if let me do this first. So of course, if it's not in the dictionary, I have to set that to 0 somehow. Right. First, and then increment by 1. So what is my final answer going to be? I'm going to go through all the groups. And then what do I do? Well, the answer is going to be, for that group, the answer will be n minus the size, right? If that's better than my current answer, I update the answer. Right? Okay. Let me see if this works. Oops. Okay. So there's some problems here. First of all, we can't actually put list as a key for dictionaries because that's not allowed. The keys to dictionaries have to be like values that can't change. For example, strings or numbers. Lists can't be keys in dictionaries because their values can change. And if you change the value of a list, right, it's not clear anymore. Like later on, if you ask, is this list in the dictionary? It's not clear because possibly the elements change or whatever. So that's not allowed. Okay, so I'm going to say something that's not very important for the solution. Pero it's okay if you don't really understand this. I can force this to work by changing this guy to a tuple. If you haven't seen this before and you're a Python programmer, you can check it out. Okay, but anyway, it's not very important. This solution is not going to work anyway because we're still spending O of n time to produce this required height sequence. And we're spending O of n time, okay, to do this operation. Skala mo O of 1 lang yan kasi group parang element access lang. But you have to be a bit careful kasi what's actually happening here is this guy is being hashed. If you understand how it works behind the scenes, may hash table yan, hinahash itong required heights, and because the required heights is a list, is an object that is O of n in length, it will roughly also take O of n to hash this guy and find the right index in the hash table to put this guy. Okay, pero anyway, it's not gonna work kasi O of n pa rin yan. But I just want to show you that the logic is at least right. Okay, let's actually try it with our example. And let me try to print the groups so that you see what I'm talking about. Okay, so our example was 423286. So yan yung groups ko. Right? If I use this required sequence, I can keep 2 elements, 4 and 8. If I use this required sequence, I can keep 2, 3, and 6. So yan. Okay, may basura dito that I don't want. But you can fix that later. I actually won't show that in the stream anymore. You can handle that later. Okay. So may issue pa rin yung solution. Ano yun? Well, we need to somehow create this required heights sequence, and that's too expensive. Is there a way for me to avoid having to create this required height sequence? Let's think about it. Do I really need to store 4, 5, 6, 7, 8, 9 just to identify this group? And so that I know like 4 belongs to that group and 8 also belongs to that group. Do I really need to know the whole sequence 4, 5, 6, 7, 8, 9? Similarly to here, do I really need to know the whole sequence 1, 2, 3, 4, 5, 6? Okay, so Walsh says subtract the min of the array from the whole array. Well, we don't really want to do that because if I subtract the min from the whole array, what's gonna happen? Magiging 0, ito magiging 0, 1, 2, 3, 4, 5. And then this one, magiging 0, 1, 2, 3, 4, 5. And I will wrongly conclude na same group sila. Pero hindi, di ba? So that's not what I really want to do, but the intuition is kind of right. Maybe there's something to do with the minimum somehow. Or maybe somehow I can do something. Okay, so Walsh says subtract the minimum of, okay, I mean the input array. So let's try that. Let's subtract the minimum from everyone. So the minimum is 2, so what's gonna happen? 2, 0, 1, 0, 6, 4. Ito ba? What do I do with this? Well, if you try your brute force, medyo ganun pa rin yung itsura, right? Magiging 2, 3, 4, 5, 6, 7. And then if I try 0, okay, magiging -1 yan. Let's ignore that for a bit for now. Okay, and then if I keep 1, doing required sequence. Well, it actually kind of looks the same as before, and I basically have the same problem, except that now I have to be a bit more careful about the negative parts even. So yeah. So maybe subtracting the minimum from everyone isn't such a good move. It doesn't change the problem too much. The problem is still basically the same. And then we just have to have, we actually change the details a little bit. Pero yung basic idea is still the same. Okay, from Naomi says, array of the minimum number to the maximum number compare I plus j and plus j of the big array. Okay, I'm sorry, I don't quite understand the comment. It's a little bit confusing. Yeah, sorry, I'm trying really hard to try to understand what your idea is, but it's not coming through. Well, sige. Let's go back. Backtrack tayo dito. So, ano ba yung idea natin so far? Well, we know if we keep an anchor element, we know what the required heights of everyone should be. And we also know that if two anchor elements have the same required height sequence, that means we can keep both of them unchanged in that ladder sequence, in that required height sequence. So we can just group everyone, all of the numbers by their required sequence, and then let's check all the groups and take the group that has the most members in it, because that means that group will have the most stools that we can leave unchanged. Right? So, pero yung problem is we don't really want to construct this required height sequence. That's going to take too long. So what do we do instead? Well, you know what? If I have a sequence that starts with 1, then the only possible ladder sequence is 1, 2, 3, 4, 5, 6. It's not possible for me to have a required height sequence that is 1, 3, 6, 7, 8, 9, right? It's always 1, 2, 3, 4, 5, 6 if the minimum element is 1. Similarly here, if the minimum element is 4, yung ladder sequence, laging 4, 5, 6, 7, 8, 9. And I can't possibly have any other sequence that starts with 4. Okay, what does that mean? It means I don't need the whole sequence to identify which group I'm in. I just need to know I can represent each group, each required height sequence by its smallest element. Right? So instead of saying group 1, 2, 3, 4, 5, 6 goes to 2, 3, 6, I can just say group 1 goes to 2, 3, 6. And then group 4 goes to 4, 8. Okay, and that will save me some time, actually a lot of time, because I don't need to construct the whole sequence. I can identify which group I belong to just by the minimum element. Okay, so I'm gonna pause a bit. There are some questions. Okay, what did I do so far? Let me look. Let me show you. Okay, let's do this again. Okay, what did we do so far? So this is our sequence. I'm gonna try to fix one guy and check how many of the others I need to replace, right? To do that, what did I do? I need to know ano dapat yung final sequence. And then I check ilan yung magkaiba, how many of them are different. And then how many are the same. Right? And if I do that for all possible stools that I fix one by one, I'm guaranteed to get the correct answer. Right? So this one, keep those, and those are not the same, and so on, right? But that's too slow because I need O of n time to produce this sequence, and I need O of n time to check are all the guys how many of these tools are correct? Do they match the sequence or not? But one thing we can notice is if you have elements that actually match, their required sequence is going to be the same. Itong 3, ano yung required sequence kung siya yung anchor? 3, 2, 1, 4, 5, 6. Itong 6, ano yung required sequence kung siya yung anchor? 6, 5, 4, 3, 2, 1. So, one way for me to get the answer is instead, try to group all the elements by their required heights. And then, I'm gonna check kung ito yung ginawa kong, if this is my ending ladder sequence, how many guys can I keep? If this is my ladder sequence, how many guys can I keep? And how do I know that? Well, all of the guys with the same ladder sequence, all of the anchors with the same ladder sequence, I can keep all of them. If the ladder sequence I'm looking at is the same as their ladder sequence. So I can group them like this. 1, 2, 3, 4, 5, 6. I know that I can keep 2, 3, and 6 kasi same yung sequence that they require. If I'm going to leave them unchanged, they will require the same sequence. So since 2, 3, and 6 all require the same sequence, if my sequence is going to end up being 1, 2, 3, 4, 5, 6, I know that I can keep 2, 3, and 6. Similarly, if my sequence is going to end up 4, 5, 6, 7, 8, 9, I know that I can keep 4 and 8. Kasi, yung sequence na required ng 4, kung i-fix ko siya, if I don't change 4, it means that the sequence must be 4, 5, 6, 7, 8, 9. If I keep 8 unchanged, the sequence must be 4, 5, 6, 7, 8, 9. So I know that my ending sequence is 4, 5, 6, 7, 8, 9. I can keep both 4 and 8. And then I have to change everyone else. Okay, so nice. So I think people get it. Yes, correct. So the last problem is we don't want to produce this whole sequence because it's expensive. But we know that we can represent the sequence just by the minimum number. Okay, so let's go to the code now. Let's implement that idea. So if you go to the code, so instead of saying required heights, let me say height of smallest tool is going to be height anchor minus anchor. Actually, let me do that in a separate window. Right? Ito yung minimum dapat na height. Right? And then same thing. And now this one is just of 1. And this one is also of 1. So we're happy. We solved the problem in O of n. And this is fast enough. And let me show you how it works with our sample sequence. Okay, so yung group, yung sequence that has 4 as the minimum element, I can keep 2 elements in it. I can keep 4 and 8. Yung sequence that starts with 1, I can keep 3 elements, 2, 3, 6. Okay, may basura dito. Kasi, magiging, kung negative 1, yung smallest sequence. But that can't happen. Kasi dapat positive yung heights. Right? So there's still a small fix that you need to do to make this solution work. Pero small detail na lang yun. So, and I think you can figure it out on your own. So, let's move on. Let me just turn on the lights. Okay, problem D now. Okay, so there's a question. What do you do for negative values? I encourage you to think about it. I don't want to spoil it for you. You should think about it. Take your time. You don't have to get it immediately now. Take your time. It's a nice mental exercise if you figure it out on your own. Okay, what happens if there's some negative thing in there? Okay, and then I'm gonna publish the code complete with the correct solution that handles the negative thing tomorrow or someday, so that you can see what the solution actually is if you didn't get it. But please try it on your own first. It's a good exercise. Okay. So the question is, well, what do we do for negative values, but it's not in the range given? Well, remember, the input values themselves cannot be negative because the problem setter guaranteed you that the inputs are positive. But we changed the sequence already, right? Or more precisely, we did this thing, right? Height anchor minus anchor. So itong heights themselves, positive yan. Pero ito, it's possibly negative. Right? Like here, in this case, nagkaroon tayo ng negative 1, 1. Kasi, kung let's say itong 2 yung anchor mo, ano mangyayari? The sequence will be negative, tama ba? Yeah. The sequence will be negative 3, negative 2, negative 1, negative 1, 0, 1, 2, 3, 4, right? Negative 1 yung smallest element. Okay? Sige. So, problem D now. Okay, paano yung problem D? Actually, if you haven't solved problem K yet, you should probably not watch this first. First, solve problem K, and then think about how to solve problem D on your own first. Okay? Kasi baka may maisip kayong magandang idea to solve D once you know how to solve K. And you can figure it out on your own. It's much, much more enjoyable if you see the idea on your own and discover it on your own. You will feel great for solving the problem on your own. So if that's you haven't solved K yet, maybe don't watch this yet. Next time na balikan nyo kung hindi nyo pa rin makuha talaga. Okay, but if you're watching this and you've solved K but don't know how to do D, then okay, let's do it now. This is how you solve D. Okay, so paano yung D? Okay, it's almost the same problem, but this time, instead of cost 1 for changing a stool, you now need to take cost absolute value x minus hi, where x is the target height. So if we change a stool of height hi into a stool of height x, you have to pay this amount. So paano yan? Actually, let's think about what we're really doing in problem K. What are we doing in problem K actually? Kung meron tayong sequence na 1, 2, 3, 4, 5, 6, in problem K, the idea is really what were we doing? H. Okay, I think I disconnected. Okay, or anyway. So ano yung idea for problem D? So in problem K, what were we doing? We're actually, if you think about it, we're kind of compressing numbers that belong to the same group into the same point. Like if you take hi minus I, it's kind of like the 1 minus 1, does a 0. 2 minus 2, 3, 4, 5, 6. Right? Or let's, going back to our example earlier, kung ganyan yung sequence natin, what's going to happen here? Ito yung hi, let me look at hi minus I. This one becomes 4, 1, 1, negative 1, right? Okay, so parang what's happening? If I pull out my number line here, okay, it's kind of like I'm squeezing the guys that belong to the same sequence to the same point. Use a different color. Do I have a different color? Oops, actually I drew it wrong. Okay, I'm squeezing them to the same point. And then what am I doing? For every group, or in other words, for every point, like count how many points that are not it, how many points that are not equal to it, how many elements are there in those points, and then get that sum. Right? So for example, for the green point, there are 5 other guys that are not mapping to the same point. So the answer for that iteration is 5. For this red point, there are 3 other guys that are not mapping to it. So 3 yung sagot. And then for this blue point, I'm just counting 4 other guys are not mapping to it. So in other words, I'm checking if the smallest tool in the sequence is X. my cost is actually, in problem K, my cost is count y not equal to x for all y in the sequence hi minus I for all I. Okay, or in other words, let me call it the representative. Okay, representative is hi minus I. The representative is what the smallest tool should be if I want element I to keep unchanged. Okay, so in problem K, the thing that I wanted to do is, if I fix x as the representative, then the cost for choosing x as the representative is how many y's are there so that y is not equal to x for all other representatives y. Right? That's problem K. Ano yung problem D na ngayon? How does this change? Well, let's say I pick this red point as my representative. Now what do I do? So yung required sequence ko ngayon ay 1, 2, 3, 4, 5, 6, right? Now notice what happens. Itong blue point, yung distance niya to this is 3. Okay, and that's exactly the amount I would need to change each of these elements in the original sequence into their required values if I chose the red guy as the representative, right? So cost 3 to make 4 into 1 and cost 3 to make 8 into 5. So pareho silang naging blue point para mapunta sila so that they belong to the same red point. To force them to be part of the same red sequence, I need to move both of them by 3 units. And then this green guy, 2 units, the 3, the 2 units yung distance niya from 1. And you can see here, that's correct, right? I need to move 2 times to turn it into the right value. Okay? So actually the problem boils down to, I'm gonna put hi minus I on the number line, and then I'm gonna find the point x so that the distances, the sum of the distances of all other points to this single point that I chose is minimized. Choose x such that sum y minus x for all y in representatives is minimized. Okay, yung kanina ito lang. Some, yung sa problem K, ganyan. But we just change it a little bit. It's actually now this instead, y minus x, actually absolute value. Okay, by the way, just to be clear, itong representatives includes the duplicates, right? So, because I need to account for that. So, itong red point, yung 1, kailangan ko ipasok sa representatives 3 times. Itong 4, itong blue point, kailangan ko ipasok 2 times. Because if I chose the red point as my representative, I need to add the cost of moving the blue point to the red point 2 times. So I need to also store the duplicates. Okay, so now I want to think, what x should I choose? Okay, I know that I can do this in O of n fairly easily. Pero itong x, that's kind of problematic kasi I have a large range of possible x's of max hi yan. And hi in the problem is 10 to the 9. So I can't just check all of them one by one. So I have to somehow pick x smartly. Well, ano ba yung x na that will work? Well, if I have a bunch of points, and I want to choose a point that minimizes the distance to everyone, let me just not draw the line. There are some obviously wrong answers, right? For example, I'm not gonna choose this point. Why not? I'm not gonna choose this point kasi, well, I can move the point closer. I can choose a closer point to everyone. Like, for example, this point. And clearly, the sum of the distances of this point to everyone, that's clearly smaller than the sum of the distances of that point, the red point, to everyone. Okay, in other words, if I move forward, if I'm outside of the range and I move closer to the range by 1, I always decrease the cost by n. Kasi the distance to everyone decreases by 1. Okay? So therefore, I can say that the x that I choose has to be at least within this range. Okay, let's examine what happens if I choose something in the middle, like this. Or some random point in between min and max. Example this. So the question is this a good point to choose? And the answer is no, it's not a good point to choose. Because I can move this green point closer, and again, I'm going to get a smaller sum. I think it's kind of intuitive. You want to put this point as close to the middle as possible. Right? If you want to minimize the sum, you somehow want to put this guy in the middle. You want to pick some point in the middle somehow. But let's see exactly why. Kasi if you didn't choose a point that is in the middle, what's gonna happen? If your if this is the middle, let's say, yeah, let's say this is the middle. And you chose a point that is to the left of this middle point, you can get a better answer by moving it closer. Choose another point that is slightly closer. And what's going to happen to the cost? Well, you made it farther away from one point, but you made it closer to n-1 other points. So your cost here increased by 1, but your cost here decreased by n-1. And if n is bigger than 1, then definitely this is better. Okay, so that means this is wrong. That's not the point you want to choose. And actually, this is still not the point you want to choose, because you can repeat this, pick another point. You will make your new point farther from a few points, but you will make it closer to more points. So you can just keep coming closer and closer to the middle. And that's sort of a proof of why choosing this median point works. Okay, and that's it. That's actually problem D. It's the same thing. You consider hi minus I instead. And now, which sequence do you want to pick? You want to pick a sequence whose middle element, whose representative, whose smallest stool is the median of all the smallest stools that you can possibly choose. And then you have to do some extra stuff to handle the negative stuff, to avoid the answer from becoming negative. But you can think about that slowly on your own, I'm sure. Okay. Yeah, it went a bit fast. So let me see if there are questions. If you have a left point with 1,000 elements and 3 right points close to each other with 1 element only. Yeah, so the important thing is, so Walsh Letran is saying, let's say for example, these are your points. Tapos, there are actually 1,000 guys going into this point. And then this one only has 1. This one only has 1. Let's give them actually labels. So let's say this is 0, 1, 2, 3, 4. 1, 2, 3. So Walsh is saying that it's not right, it's not correct to keep moving to the median, because you're moving farther away from 1,000 points to the left and moving closer to only 3 points on the right. And that's correct. That's correct if you only consider 0, 1, 2, and 3. But we can fix that. We'll actually include the duplicates. So I mentioned this a bit earlier. It's important that you keep the duplicates. So what's going to happen is, yung representatives mo is not going to be just 0, 1, 2, 3. You're going to have 0, 0, 0, 1,000 times 1, 2, 3. And now it's clear that, yes, it's the median that will minimize the distance to everyone else. Okay. Bawal yung 0 sa problem. Let's change this a bit. Yeah. So if you take the median of this list, then you'll get the correct answer. Yeah, right? So it's kind of like, yeah, you need to include the duplicates so that they parang their weight, parang the weight of this 1000 is represented by the is the 1000 elements here properly reflects is properly reflected in this list. Right? And you can repeat the same argument and it will work. Right? Because now, even if there are duplicates, right, it doesn't matter. What I said above is still true. That if you okay, let's say there's a duplicate point there. There's 2 points at this x-axis, at this x coordinate, and then you have a bunch of points there. Even if there are duplicates, right, you're moving away from 2 points, but you're moving closer to more points to the right. So the argument still holds, even if there are duplicates in the list. Okay, so how about something like 22222 100,000? So yeah, the median of that list is going to be 2, right? And you can think about it. The argument still works, right? You don't want to move to 50,000 or something, right? That would be the median if you only consider 2 and 100,000. There's only 2 items in your list. Right? You can think about why it still works. Okay, so that was problem D, and I think I'll end the stream here. I won't show the code anymore for problem D. Maybe I'll show it in the notes, but I think the guys who made it up to problem D will know what to do and how to implement this in code. Let me read the comment. At 100,000, you lose 998 times 4. Yeah. Yeah. Alright, so yeah, I'll end the stream here. I hope you guys enjoyed the problems. And yeah, all my questions pa, you can always ask in the Discord channel. If you're not part of the Discord server yet, you can email us at ask.noi.ph with your name, school, and grade level, and we'll give you access. Okay? Or you can comment on our Facebook page or message us in our Facebook page. So that's all for today's stream. I hope you guys learned something, learned lots of things. Just follow our Facebook page and YouTube. Subscribe to our YouTube channel so that you stay updated if you haven't done so. Alright, that's all for now. Goodbye, see you.